Greetings to all. I am here, your chemistry teacher. I am going to teach you the first lesson of 12th standard chemistry book, that is metallurgy. Now, we know about metals. Metals have very distinguished, unique property of conduction. And these metals are obtained from the natural sources available. So in this lesson, we are going to study how a particular metal is extracted from its natural resource. So let us go into the topic now. So metallurgy is a science and technology, deals with the extraction of metals from the natural resources. Okay? Fine. Now, first of all, we have to know about what is a mineral and what is an ore. Now, what is a mineral? All metallic compounds that exist in nature are called as minerals. When you see metals, for example, gold, silver, platinum, these are all obtained in the elemental state. And other metals like copper, calcium, nickel, they are all obtained from the natural resource as its compound, like calcium carbonate and nickel sulfate, like that. So we have to take that minerals and then we have to extract the metal. So this is what is mineral. So mineral is the chemical combination of a metal with the other elements which is available in the nature. Right? Okay, then what is an ore? Ore is a chemical compound or a metallic compound from which the metal is extracted. To separate a ore from mineral, we have three important things that have to be kept in mind. First of all, the mineral should have highest percentage of the metal. That particular mineral will be taken as a ore. First one, having higher percentage of the metal. Second one, the mineral from which the metal is extracted, that process should be an easier process. Just by heating or just by melting, just by oxidizing, just by reducing, it should be obtained very easily. So easier process should be there. Third one, that process should be more economical. So when these three criteria comes together for a mineral, that mineral is called as a ore. All ores are minerals, but not all minerals are ores. So if a mineral have to become an ore, has to satisfy three conditions. First of all, it should contain a higher percentage of the metal. Second one, it should be easy to separate or extract. Third one, this process should be very economical. Fine, you understood? Very clear? Mineral ores. Now we will go into the metallurgical process. In this metallurgical process, there are three processes that I have listed out. First one, concentration of ores, then extraction of crude metal, then refining of the crude metal. Now today I am going to talk about only the first part, that is concentration of ores. See, the ores which are obtained from the nature contains non-metallic impurities, rocky materials and siliceous matter which has to be removed. All these impurities are together called as gangue. This gangue should be removed from the ore. So for that, we are using this concentration process. Now coming to concentration process, we have got gravity separation process, or otherwise it is called as hydraulic wash. Second one is froth flotation process. And third one is leaching process or chemical leaching process. Generally this is a chemical method. And fourth one is magnetic separation. So all these four methods are used to concentrate an ore. That is to remove the gangue particles from the ore. Let's talk about the first one, gravity separation. What is this used for? As you see here, this method is used to separate the heavy ores. In other words, ores having higher specific gravity. Okay, so ores which has higher specific gravity will have more weight or mass. So those kind of ores, for example oxide ores, they will be separated by this method. What is this method? It is nothing but you allow water to run from a slope. You just allow water to run from a slope. So it is a running water is there, and you powder the ore, finely powdered ore, and put it in the running water. What will happen? Those ores which are having higher specific gravity will go down and settle because of this gravity, and those impurities or gangue particles which is having lower specific gravity will be washed away by the water. This is a simple method which we call it as gravity separation method. Okay. Second one, froth flotation method. This is another important method which is used for light ores, ores which is having lower specific gravity, other words. Okay. So here what we are going to do is, you are going to put the finely powdered ore in water. The basic principle of this froth flotation is that these kind of ores can be wetted more by oil than by water. That is, these ores will combine with oily substances rather than with water. So when the powdered ore is put into the water, and when you add any oil, for example pine oil or palm oil, eucalyptus oil, when you add those two oils inside it, this oil will mix with the ore, and when air is blown into the water, froth is obtained or froth will be produced. Along with this froth, the lighter ores will come up. To initiate this or to help this, we are using sodium ethyl xanthate as a collector. The role of the collector here is, the sodium ethyl xanthate will make the ore to get wetted in oil rather than in water. So water repulsion property will be given by this collector. So now the ore is mixed with the froth and comes out, and then you separate the froth and you separate the ore. And here one more thing is that is, for suppose if you have a sulfide ore, a zinc sulfide, and you have another sulfide, another metal sulfide as an impurity. So how to separate that? We want only zinc sulfide. We don't want other metal sulfides. So for that, you will have to use a depressing agent like sodium cyanide, sodium carbonate. These depressing agents will make the lighter ore, sulfide ore, to come along with the froth, and the heavier sulfide ore will get settled. So that is why we are going in for this depressing agents. Okay. So one is, when you talk about froth flotation, there are three things. One is the chemical or the compound which is used to produce froth, that is oil, pine oil or eucalyptus oil. Second one is collector, role of the collector, which makes the ore to get wetted in the oil rather than the water. Third one is depressing agent. This is in case of other metal sulfides which disturbs the metal sulfide that we want to get. Okay, fine. And let's go to the third one. This is chemical leaching. Leaching is washing. So here what is the principle is that any ore will be converted into a pure coordinate substance or coordinate compound, and then it is made to react with another elements or another metal to give the original ore. Simple method. Here first one, cyanide leaching. Here cyanide ion is used. Let's take Au, that is gold. Gold reacts with either potassium cyanide or sodium cyanide ion in presence of air and water. it gives you a coordination compound of gold. This coordination compound is separated and made to react with zinc to give back the ore that we want. So this is cyanide leaching. And second one is ammonia leaching. Here we are going to use liquid ammonia. So when you take liquid ammonia and made it to react with any ore like nickel ore or copper ore or chromium ore, they form a coordination compound like this, which is then taken out, separated and treated by some method, some proper method like any metal or just by heating, you will get back the ore. So this is ammonia leaching. And the third one is alkali leaching. Alkali, we know sodium hydroxide, potassium hydroxide. Here, let's take aluminium. Bauxite is the ore we know, Al2O3. This is made to react with sodium hydroxide in presence of water, and you will get sodium metaaluminate first of all, very hot solution, and then it is decanted and cooled and made to react with carbon dioxide to give back the ore. This ore is again heated to give back the pure ore that we wanted. Okay, so this is we are using an alkali. Then we'll come back to the acid leaching. There you see here H2SO4 is an acid that has been used, that is sulfuric acid. In presence of oxygen, we make it to react to give. Here sulfide ore is converted to zinc sulfate and sulfur. Here we use acid for leaching. Okay, so these are the 4 chemical leaching methods that we have. And lastly, we come down to the magnetic separation. What is magnetic separation? This is mainly mainly used where either the ore is having magnetic character or the gangue will be having the magnetic character. You want to separate the ore which is having magnetic character from the non-metallic or non-magnetic gangue, or non-magnetic ore is separated from the magnetic gangue. You understand what I am trying to say? Okay, for this we are using this. Now how to do this? As you see here, this ferromagnetic ores, this is mainly, the principle is that it is mainly used based on the difference in magnetic properties. Okay, so now for example wolframite ore, it is crushed and there are 2 rollers and there is a conveyor belt, and so there 2 rollers are there and 2 conveyor belt will be going on running, and one particular roller will be magnetized or magnetic nature. So when the roller moves, when the crushed ore is put on the belt, it moves to one side. So those particles which is having magnetic behavior get attracted by the roller and fell towards very close to that of the roller, and those which do not have magnetic character will go away and fall away from this belt. So that's how this magnetic separation works. A very simple method. So today we have talked about metallurgy, minerals and ores, and the concentration of ores. There are 4 types of concentration of ores. Next class we will talk about extraction of this crude metal and refining of crude metal. Okay, thank you.